Machine pencil cartography. So today I wanted to introduce the concepts of high-speed craft. Interestingly, the terminology of high-speed craft actually comes from the International Maritime Organization, which maintains the definition of high-speed craft for use in maritime operations nomenclature. Famously, a naval craft might travel as fast as 240 nautical miles per hour, or 240 knots, which is the exact speed required to travel 3 time zones away in 1 hour at the equator. So this is hilariously fast. I mean, honestly, 240 miles per hour is very good. So as a navigator though, the reality is that I will often travel over land instead of over water. Even though I recognize the legitimacy of transportation over water, perhaps marine transport and ground transport can share the spotlight. This is what I personally hope for. So my plan is to discuss the nuances of traveling overland. First of all, they call this express travel, and express travel is direct and to the point, and differs from cruising transport in important ways. Namely, cruising transport is when you travel at intentionally slow speeds because you are having excellent site visitation, and cruising is basically when you aimlessly wander from place to place without priorities. They use the concept of fast travel in video games frequently because gamers don't have the patience to navigate around the map, and they will often just choose to teleport where they want to go. So, in the spirit of professionalism, this will be referred to as express transportation. Interestingly, a major failure mode of your vehicle when you're moving at high speeds is engine overheating and having car fires. So, when moving at high speeds, the vehicle's cooling system is a consideration that is extremely important. If you travel on the expressway often, then as the vehicle's operator, it is crucial to plan how your driving attitudes will contribute towards the vehicle not catching on fire. Because having car fires is a specific ergonomic attitude, which is especially relevant when you are traveling on an expressway, because your car catching fire is considered an excitation mechanic. Excitation mechanics. So these are actually interesting ergonomic and rheological occurrences. Excitation mechanics are actually siblings of encumbrance mechanics. When examining the ergonomics of a vehicle, the vehicle will exhibit new attitudes when the vehicle is taken into high-speed regiments of operation, that the vehicle will never exhibit when the vehicle is utilized in low-speed operations. And the entire concept of excitation mechanics is that excitation mechanics only occur at high speeds of operation. An excellent example of an excitation mechanic is that when you fly a jet at supersonic speeds, it is commonly known that when your airplane breaks Mach 1, the aircraft will create a vortex, and this vortex is known as a sonic boom. The sonic boom is an iconic image for an excitation mechanic because, as you know, the sonic boom is a nouvelle occurrence that will happen when an aircraft breaks the minimum speed limit for this to occur, which is the speed of sound, 670 knots or 1200 kilometers per hour. Excitation mechanics are something that are definitely worth remembering and will absolutely be one of the most important lessons in this video. High-speed craft also have larger turning radiuses because turning too tightly while moving at high speeds will result in your vehicle losing balance and having rollover accidents. Therefore, if you want to go faster, you can plan to perform jug-handle turns more often because you are planning to have larger turning radiuses. When discussing high-speed craft, collision control is also a serious issue, and you need to plan a route where the collision control will be mitigated. This is a serious reason why overland transport is actually much slower in practice than transportation over water, and also transportation in the air. Because the traffic densities and the number of obstructions in the water or in the sky are much more sparse, resulting in low-risk transportation. Because there are such high barriers to entry into avian or naval transportation, the result will be that the base probability of collisions is almost zero. The reason why expressways allow fast travel is because expressways are dedicated roadways for coherent traffic, and this traffic is completely tranquil motion, where if you examine an expressway on a map, the expressway is actually curved because these are the turning radiuses of ground transportation carriers. Another interesting fact is that the line obstructions of expressways also often form the natural boundaries between townships and urban environments, which means that there is a relationship between the turning radius of a car and the geographical boundaries that are drawn on a map. Because the turning radius on the car will be the sole determining factor in what these large-scale geographical shapes look like. Thanks, guys. This has been Machine Pencil Cartography, signing out.